Hello everyone and welcome back to Study Room. In the previous lecture, I taught you factorization of algebraic expression using some of the well-known identities. And over there, I taught you 4 important identities. I hope you all remember that. In today's lecture, we'll be dealing with division of algebraic expressions. We will learn how can we divide different types of algebraic expressions with each other and draw some sort of conclusions. So let's get started. Before starting the main topic of division of algebraic expressions, I want you all to make some observation. So, over here we have 2x multiplied with 3x squared. Now, 2 multiplied with 3 gives us 6 and x multiplied with x squared gives us x cubed. So, ultimately 2x multiplied with 3x squared gives us 3x cubed. Now, let us do one thing. Let us divide the 6x cubed with 3x squared. That means let us take 6x cubed as the dividend. Let us take it as the dividend. And let us take 3x squared as the divisor. Now, let us divide it. So, we have to divide 6x cubed by 3x squared. Now, this can be done in this way, that we have to write 6x cubed and then multiplied with 1 by 3x squared. Because when we convert the sign of division to multiplication, we take the reciprocal of the term that is after, the second term. So, we took the reciprocal of 3x squared, that is 1 by 3x squared. Now, this 3 will get cancelled up with 6, leaving behind 2. So, we have over here 2. Now, what about this x cube and x squared? When x cube is getting divided with x squared, I have taught you this in algebraic exponents in power. When bases are same and they are getting divided, then their powers will be subtracted. That means we will be left with x power 3 minus 2, which is equal to x power 1, which can be written as x. So, our answer will be 2 times of x, because 3 gets cancelled out with 6 leaving behind 2, and x cubed divided by x square gives us x. So, 2x is our quotient, of course, because when 6x cubed is the dividend and 3x squared is the divisor, then 2x is the quotient that we get. This is the quotient. So the observation I want you all to draw from over here is this 2x is the quotient. That in case of division of algebraic expression, this quotient multiplied with the divisor gives us the dividend. This is a very important thing. In usual, what we know is, we know that dividend is equal to divisor multiplied with quotient plus of remainder. In case of algebraic expression, when we are solving the division part, then what we have is, we have dividend is equal to divisor multiplied with the quotient. Let us check this in another expression. Okay, so over here we have 5x, which is getting multiplied with x plus 4. Now, when we multiply 5x with x, we get 5x square, and then when we multiply 5x with 4, we get 20x. Let us take this as the dividend, okay? Take this as the dividend. Now, let us take 5x as the divisor in this case. This is the divisor. And let's start dividing. So, what we have to do is, we have to divide this 5x square plus 20x with 5 times of x. So, in order to do this, we can represent it as 5x square plus of 20 and then give a division sign like this, and in the denominator write 5x. From the numerator, now observe, I have taught you this in the previous lesson, that from 5x square and 20x, we can take common factors outside the bracket. We have 5 as a common factor and we have x as a common factor, because we have 5 in both the terms and x in both the terms. Now, when 5x has been taken common outside from the first term, we are left with x. And when from 20x, when we have taken 5x common, we are left with 4. Because 5x multiplied with 4 gives us 20x. And then in the denominator, we have 5x. Now, why did we take out the common factor? Because this 5x will get cancelled out with this 5x, and thereby x plus 4 will be left as the quotient. So, we took this 5x as the divisor, x plus 4 came as the quotient, and this entire thing was the dividend. So, again, the same thing is following, that divisor multiplied with the quotient is giving us the dividend. Isn't it? So, this is a conclusion in case of algebraic expressions. The first thing that we'll be learning in case of division of algebraic expression is a division of a monomial by a monomial. Now, what was a monomial? A monomial was an algebraic expression consisting of just a single term. So, we will be given with two monomials and we have to divide them. For example, over here we have 6x cubed. This is a monomial because it is an expression with just a single term. And we have to divide it with 2x. Let's do it. What we have to do is we have to write 6x cubed and then give a division sign and divide it with 2x. Now, this 2 will get cancelled up with 6 leaving behind 3. Now, what we have to do is we have to divide this x cubed with x. That means x cubed needs to be divided with x. I told you that when bases are same and they are divided, the powers will be subtracted. That means x to the power of 3 minus 1 because over here the power of x is 1. The power of x is 3 over here. So we have 3 minus 1 ultimately which gives us x squared. So this is a calculation that you should do it in the rough column. Okay. Now what we are left with is we are left with 3. And we can say then when x cubed gets divided with x, it leaves behind x squared. So x can be cancelled up with x cubed, leaving behind x squared. So our answer will be, that means our quotient will be 3 times of x squared. This is what we are left with. So when we divide 6x cubed with 2x, our quotient comes as 3x squared. Let's try dividing some more monomials with monomials. So the next question that we have is minus 20x to the power 4 is getting divided with 10x squared. That means this is the dividend and this is the divisor. Okay, this is the divisor. And when we divide the dividend with the divisor, what will we get? We'll get a quotient. Okay, so let's try solving this. The first problem that we have is minus of 20x to the power 4. Now it is getting divided, so I can write it in this way, divided by 10 times of x squared. Now this 10 will get cancelled up with minus 20, leaving behind minus of 2, isn't it? 10 minus 20, 10 minus 2 times gives us minus 20. Now what about x squared and x to the power of 4? We have to divide x squared with x to the power 4. That means x to the power 4 is getting divided with x squared. When bases are same, their powers will be subtracted. That means x to the power of 4 minus 2, which gives us x squared. So we'll be left with, over here we can see that x squared will get cancelled up with x to the power 4, leaving behind x squared. So we'll be left with minus 2 multiplied with x squared, which gives us minus of 2 times x squared. So this will be our answer when we divide minus 20x to the power 4 with 10x squared. Let's solve the second problem we have. So the second problem we have is 7 times x squared, y squared, z squared is divided with 14 times x, y and z. Now 7 will get cancelled up with 14 leaving behind 2. Now what we have to do is we have to check the like bases and then divide it. So in the first place we have x square is getting divided with x. That means we have x square is getting divided with x. So when bases are same, their powers will be subtracted. That will give us x to the power of 2 minus 1, which is equal to x. Again we have y square divided by y. Right? Here we have y square and in the denominator we have y. So y square divided by y will give us y to the power of 2 minus 1, which is again equal to y. In the similar way, we have z square divided by z. So this will give us z to the power of 2 minus 1 because when bases are same, their powers will be subtracted, will be equal to z. So from here we can say that this x, y and z will get cancelled up with x square, y square and z square, leaving behind x, y and z. Because x gets cancelled out with x square leaving behind x, y get cancelled out with y square leaving behind y and z gets cancelled out with z square leaving behind z. So our answer will be x, y, z and in the denominator we'll be having 2. So this is the answer when we divide 7x square, y square, z square with 14xyz. Now I'll be teaching you a second type of division, that is division of a polynomial with a monomial. Earlier we learnt about division of a monomial and monomial. Now we'll be doing polynomial divided with a monomial. So we have an example over here. That is, we have been given a polynomial that is 4y cubed plus 5y square plus 6y, and we have to divide it with a monomial that is 2 times of y. So how to represent it? We can simply write it as 4y cubed plus of 5 times of y square plus of 6 times y, and we have to whole divide it with 2 times of y. Now what we can do is, in these types of problem, we can separate the terms. Separating the terms mean we will take the first term of the numerator and then divide it with the denominator. Then take the second term of the numerator, divide the denominator, and then take the third term and divide with the denominator and write each of the terms in addition form. I'll explain you. First, what you have to write is 4y cubed divided by 2 times y. Because this entire term is divided by 2 times means that each of the term is getting divided by 2y. So I have taken the first term 4y square and divided it with 2y. Now I'll give an addition sign, and then the second term I have is 5 times of y square. Again it will get divided with the denominator that is 2 times of y. The third term that I have is plus of 6 times y. It will again get divided by the denominator that is 2y. Now can you observe one thing? We have got the division of a monomial and monomial. This first thing is division of a monomial. Again, this is also monomial division, and this third term is also monomial division, which I have already taught you. Now you will be able to solve it very easily. So what we have to do is, this 2 will get cancelled up with 4 leaving behind 2. Now y will get cancelled out with y cube leaving behind y square. Why? Because y cube is getting divided with y square. Sorry, y. We know when the bases are same, then their powers will be subtracted. That means y to the power of 3 minus 1, which is equal to y square. So we can say that y square times gives y cube. So here we have 2 and y square in the numerator. 2 multiplied with y square gives us 2y square from the first term. That means after dividing the first term, we are left with 2y square. Now moving on to the next term. Here we have 5 by 2. Now we cannot cancel this integral part. 5 by 2 cannot get cancelled out. We have y square divided by y. Now we'll be doing it directly. Y square by y. Bases are same. Powers will be subtracted. Power is 2 over here and 1 over here. That means 2 minus 1, 1. So we'll be left with y on the numerator side. So from here we will get 5 by 2y. Because this y gets cancelled up with y square leaving behind just y. So 5 multiplied with y gives us, 5 by 2 multiplied with y gives us 5 by 2y. Now what about the third term? Over here 2 can get cancelled up with 6 leaving behind 3, and this y can get cancelled up with y. Because when we have the same thing in the numerator and the denominator, they can get cancelled up. Y 1 times y. So 3 multiplied with 1 gives us 3. So this will be our answer. That is 2y square plus 5 by 2y plus of 3. The next problem that we have with us over here is divide 24x square yz plus xy square z plus xyz square by 8xyz using both methods. Now what do you mean by both methods? By both methods, they mean that the first method is to break this polynomial into monomials, and then we have to do monomial division. Or we can do the second method, that is the method of common factor. And then I'll be showing you both the method. You choose which one suits you the best. That means which one you find is more easy. So the first method is separating each of the terms and using the monomial division method. So first of all, I'll be writing the first thing, that is the dividend, that is 24 multiplied with x square yz plus of x y square z plus of xy, and we have z square, and this is whole divided with 8xyz. Now the very first thing we'll do it, we'll cancel up this 8 with 24, that gives us 3, and take this 3 outside the bracket and do the entire division within the bracket. Now what we'll do is we'll break each of these terms of the polynomial with this divisor. That means we will break each of these terms in such a way that we'll be getting a monomial division. So the first term we'll have is x square yz, which is divided with xyz, The second term we'll have is x y square z, which will be divided with the same divisor, that is xyz. And the third term is xyz square, which will be divided with the same divisor, that is xyz. Now, 3 is outside. When we divide x square yz with xyz, first of all, yz will get cancelled out with yz. Now, what is x square divided by x? What do you mean by x square divided by x? Do you remember exponents in power? When bases are same and they are divided, their powers will be subtracted. So, the powers are subtracted, x to the power of 2 minus 1, which gives us x to the power 1, which can be written as x. So, from the first term, we get x. In the similar way, this x will get cancelled out with this x, z gets cancelled out with this z. Y square divided by y will give us y. Because when bases are same and they are divided, powers will be subtracted. Similarly, in this third term, xy will get cancelled out. We will be left with z square divided by z. Z square divided by z will give us z. Because when bases are same and they are divided, powers are subtracted. Z to the power of 2 minus 1, which ultimately gives us z. So this will be our answer. That is x multiplied with 3 whole multiplied with x plus y plus z. You can call it the quotient or answer as you wish. Now, let us try doing this very sum with another method, that is the method of common factor. I consider this method much more easier than the previous method. Let me show you this method. In this method, what we do is, I'll be writing the first dividend, that is 24x square yz plus of x y square z, and then this is added up with x y z square. And this entire thing is getting divided with 8 times of x, y, z. Now what you have to do is, we'll be taking common factors from each of these 3 terms outside. Now observe what is the common factor. First of all, x is there in all the 3 terms. Again, y is also there in all the 3 terms and z is also there in all the 3 terms. So can we say that x, y, z are the common factor of each of these 3 terms? So we can take x, y, z outside the bracket? Yes, we can. So we'll be left with 24 x, y, z. This x, y, z has been taken common outside from each of the terms. Now when I take x, y, z common from the first term, I'll be left with x. Because when x, y, z gets multiplied with x, we get x square y, z. In the similar way, from the second term, we'll be remaining with y, and from the third term, we will get z. Because when x, y, z is multiplied with y, we get the second term, that is x, y square z. And when x, y, z is multiplied with z, we get the third term, that is x, y, z square. Now, we'll be writing the denominator, that is the divisor 8x, y, z. 8 gets cancelled out with 24, leaving behind 3. xy gets entirely cancelled out with xyz. So we'll be left with 3 times of x plus y plus of z. So from here we can conclude that from either of the 2 methods, our answer will be the same. Both the methods will get the same answer, but it's up to you to choose from the 2 methods. One is breaking the polynomial into a monomial division, and the other is the method of common factor. Now we'll be solving another problem using the method of common factor. So here we have a polynomial. This is 7x square plus 4x, and this x plus 2 is again a polynomial. So what we have with us is polynomial division. Now you must remember one thing, that in case of polynomial division, we cannot break it into monomial division. The only method left with us is the method of common factor. Got it? So what we'll do, we'll be using the method of common factor. So we have 7x square plus of 14x, and we have to divide this with x plus of 2. Now, we'll be taking out the common factors from the dividend, that is 7x square and 14x. Now, 7x square and 14x, what are the common terms? Let me first break it down. 7x square can be written as 7 multiplied with x multiplied with x. This is just for the sake of understanding. And then 14x can be written as 7 multiplied with 2 multiplied with x. So from here I can see that I can take 7 outside because 7 is common to both the terms. then x is also a common factor of both the terms. So 7x is the common factor of both the term which can be taken outside the bracket 7x. So when I took 7x outside from the first term, I'll be left with x. This is x which I am left with from the first term. Now when I took 7x outside from the second term, I am left with plus of 2. So plus 2 is left behind. So we have in the denominator as x plus 2. Now what will happen is this x plus 2 will get entirely cancelled out with x plus 2, and thus the quotient that will be left is 7 times of x. So this is our required quotient of the given division, 7x square plus 14x divided by x plus 2. Now let's try solving another question. The question given to us over here is 44x to the power 4 minus of 5x cube minus 24x square plus 11x multiplied with x minus 8. We'll be solving this question by the method of common factor. This is a polynomial division, and we can only solve it by using the method of common factor. So what we'll be doing first? The first thing that we'll be doing is we have to observe this term. Now, is there any common factor in this term? Yes, I can find it. So first, let me reduce this term so that it will be easier for you to figure out the common factors. X to the power 4 can be written as x square multiplied with x square. Minus 5x cube can be written as minus of 5x multiplied with x square. And minus 24x square can be written as minus 24 multiplied with x square. Now, we'll divide it and use this common factor method. First up, we have 44x to the power of 4 minus of 5x cube minus of 24x square as the dividend given to us. We have to divide this entire thing with 11 times of x whole multiplied with x minus of 8. Now what we have to do is, we have to take common factor outside from this numerator thing. The common factor over here is x square. See, we have x square in the first term, x square in the second term, and x square in the third term as well. So let's take it outside the bracket. So we'll be left with 44 multiplied with x square, and we'll be left with x square in the first term. Now what's left in the second term? Minus of 5 times x. So we have minus of 5 times x. And then when we take out x square from the third term, we'll be left with minus 24. So we have minus 24. Now over here we have 11x multiplied with x minus of 8. This 11 gets cancelled out with 44 leaving behind 4. X gets cancelled out with x square leaving behind x. So we'll be left with 4 times of x, and over here we'll be left with x square minus of 5x minus of 24, and this thing is whole divided with x minus of 8. Now what we have to do over here is, over here this x square minus 5x minus 24, we'll be using the the fourth identity that I taught you. What was the fourth identity? Let's recall it. The fourth identity was that if we have x square plus of a plus b of x plus of ab, then that can be written as x plus a multiplied with x plus of b. This was a very important identity and it will be used in many places. So we'll be using it over here. So the basic logic of using this identity was that this product of AB should be taken. That means A and B should be taken in such a way that this product AB gives us the numerical component, that is minus 24, and the sum of AB, that is A plus B, should be taken in such a way that it is equal to the coefficient of x over here, which is minus 5. Let me explain. I have to take A and B in such a way such that the product of this AB, A multiplied with B, gives me the numerical component which is equal to minus of 24. And its sum, that is A plus B, should be equal to the coefficient of this x. Coefficient of x means the term preceding x is minus of 5. So this sum should be equal to minus of 5. This is a very important thing that you need to remember in this fourth identity, that the product should be equal to the numerical component, and the sum of this A plus B should be equal to the coefficient of x. Now, take a plus b in such a way that its product gives you 24. So we can take a as minus 8 and b as 3. Minus 8 multiplied with 3 gives me minus 24. Now you have to check that whether the sum of a plus b is giving me minus 5 or not. Sum means minus 8 plus 3 is equal to minus 5. Yes, I am getting. So the value of a I am taking is minus 8 and b will be 3. So what I have to do is I have to write 4 times of x and then we have to reduce this. First of all, we have x square minus 5x minus 24. This can be reduced as x square minus of 8 times x plus of 3 times of x plus of minus of 8 multiplied with plus of 3. So this is the way we have reduced x square minus 5x minus 24 in terms of a and b. And this is whole divided with x minus of 8. Now what we have to do is, we have this 4x as it is. Now what we have to do is to take x common from these two terms. So we'll be left with x square, within bracket we'll have minus 8 plus 3 and then x, and over here we have minus of 8 multiplied with 3. And then it is whole divided by x minus of 8. Now we'll be using the fourth identity, that is x square plus of a plus bx plus ab gives us x plus a multiplied with x plus b. So over here we have 4 times of x and then we have to write x plus a. What we have taken? A minus 8. So it will be x of minus 8 because x plus minus 8 gives us x minus 8. And then we have to multiply it with x plus b. What is b? b is 3. So it will be x plus of 3 whole divided by x minus of 8. Now, by using the common factor method, we can see that is this x minus 8 gets cancelled out with x minus 8, leaving behind 4 times x plus 3 as the quotient. So this will be our final answer, which is the quotient when we divide these two given polynomials. Now we have another problem, that is z multiplied with 5x square minus 80 and we have to divide this with 5x whole multiplied with z plus 4. I'll be teaching you a different and a unique method of solving this problem, and in this problem you will be using all the previous concepts that I taught, that is the concept of common factor method, the concept of identities, and we'll be dividing it in that way. You can of course divide it with a long division method by first opening the brackets and then solving it. But this method is an interesting one. So let's do it. So what you have to do is, this is the dividend and this is the divisor. So I'll be writing the dividend on the numerator, that is z multiplied with 5z square minus 18, and we have to divide this whole thing with 5z multiplied with z plus of 4. Now, from this numerator thing, what is the common factor between 5z square and 18? Is there anything common in 5z square and 18? Yes, it is. We have 5 as a common factor. So we'll be taking 5 outside the bracket. We already have z. We have taken 5 outside. So we will have 5 times of z. Where did this 5 come from? I have taken it common from these two terms. So when I took this 5 common outside, the first term within the bracket that is left is z square. And the second term that is left is, wait, I'll show you. 80 can be written, this minus 18, it can be written as minus of 5 multiplied with 16. So when I took minus this 5 common outside, I'll be left with minus of 16. So over here I have minus of 16. I hope you got my point, how I'm getting minus 16. I took 5 common outside and we know that 5 multiplied with 16 gives us 80. So I'm left with 16 over here. The denominator will remain as it is, that is 5 times of z, and then we have whole multiplied with z plus of 4. Now, what we can do is, this 5z will get cancelled out with this 5z. So we are left with z square minus 16 on the numerator and z plus 4 on the denominator. Now this z square minus 16 can also be written as z square minus of 16 can be written as 4 whole square. Because we know that 16 is equal to 4 multiplied with 4, which is equal to 4 whole square. And then the denominator remains the same, that is z plus 4. Now we'll be using the third identity that I taught you, that is a square minus b square is equal to a plus b multiplied with a minus b. Can we use it over here? A square minus of b square will be equal to a plus b multiplied with a minus b. A over here is z. So we'll have z plus a, that is plus 4, because b over here is 4. If I am comparing this with the standard identity. So it will be z square minus 4 square will give me z plus 4 whole multiplied with z minus of 4. Now in the denominator I have z plus of 4. So this z plus 4 will get cancelled out with this z plus 4, leaving behind z minus 4. The z minus 4 is the quotient. Now how will you check it? Just multiply this quotient with the divisor. You will be getting the quotient, because divisor multiplied with quotient gives us the dividend, isn't it? So this was the end of today's session. Thank you so much for joining me on Study Room. Hope to meet you in the next video, where I'll be giving you a quick recap of the entire chapter.